Problems 16 and 17 ask us to determine the domain and range of these continuous functions. Continuous as in these are functions that are graphed with a line, not just with individual plotted points. Notice I have points on the end, and in one case, over here at -6, -4, I have an open circle. The opposite end at 8, 3, I have a closed circle. So I need to write my domain and my range for this continuous function. Again, there are an infinite number of numbers between these 2 points, so I have to write it as kind of an in-between. So I write my x and I write my less than signs on either side of the x. And now I need to start with my lowest possible domain value, which is a -6. Notice this is an open circle, not a closed circle. The open circle indicates that the -6 is not a part of that particular graph. On the other side, where I have an 8 as my highest value, it's all the way to the right on this particular function. That one is going to be closed. This circle on the left is open. The circle on the right is closed. So as a result of that, I will put a line under my inequality on the right-hand side because 8 is included in the domain, but I won't do that on the left. And so I have -6 is less than or equal to x, which is less than x, which is less than or equal to 8. For the range, I set this up with y in the center of my inequalities instead of x because the range values are y values. I look at the lowest possible part of this graph and I notice that it's right there at -4. Again, that's an open circle, so I don't put a line underneath my inequality. At the highest, my y value is a 3, and that's a closed circle, so I will write a line underneath it there. On 17, though, the situation is a little bit different. So again, I have a continuous function. I have a point at either end of this function, one point that is closed and one point that is open. The point on the far left is -4, 4. On the far right, my point is going to be 1, -1. So for my domain, I will set this up in a very similar fashion to how I set up problem number 16. My domain values are x values, so I'll write an x. I will put less than signs on both sides of the x. I'm going to start by looking at the point the farthest to the left, and that's that closed circle. It's a -4. Closed means that it is included, so I will write my equality line underneath the less than symbol. But on the opposite side, it's open. So where x is a 1, I don't write an equality line under my less than symbol. So there's my domain. -4 is less than or equal to x, which is less than 1. My range, I need to set up the same way I set up my range on problem number 16. In this particular case, I'll write a y. I'll put my less than signs on both sides of it. The highest point on this particular function is there at 4. I need to write that on the right-hand side of this. My highest values go on the right, my lowest on the left. But notice, since that's a closed circle and that circle is the highest point, I put an equals to line under my inequality. I want you to notice, though, that the open circle is not the lowest point on this function. That's down here at -5, and that's a solid line. And that solid line means that -5 is included in this graph. So I have to put my equals to sign underneath. And my range is -5 is less than or equal to y, which is less than or equal to 4. Let's look at problem number 18. It says, which of the following best represents the range of the function shown below? My range values are y values. I draw a line there because that's the lowest point on this graph. Every possible y value above that point will be somewhere on this graph. And that's at a -2. So that's important to note. So let's go through and let's see if we can write a statement, an inequality statement that would capture this. In this case, y is greater than or equal to every value above a -2. So I can just write y is greater than or equal to -2. So let's see which of these possible answer choices match up with that. Well, when I look at A, it says the range is all real numbers. But that's not true. There are a lot of numbers, and they're all underneath that green line, that are not included in this range. So answer choice A is wrong. Answer choice B looks a little bit promising. The range is all real numbers greater than or equal to -2. But let's check the others out just to make sure we didn't make a mistake. When I look at C, it says the range is all real numbers greater than or equal to a +2. But notice there are numbers that are beneath that line, so it's not C. Same thing with D. There are numbers beneath the 0. And so I know that my answer choice is B. The range is all real numbers greater than or equal to a -2. Let's take a look at number 19 next. If the domain of the graph on the right is restricted to the set of all x such that x is 2 is less than or equal to x is less than or equal to 4, what is the corresponding range? So in this particular case, if I'm restricting the domain of this graph to everywhere between 2 and 4, I want to do something on the graph to indicate that that's the slice that I'm looking at. So I'm going to go ahead and draw vertical lines at 2 and at 4, because it's only the y values in between the 2 and the 4 that I will be interested in here. So I go ahead and I draw those out. That gives me a nice visual. And I'm looking at the y values that are in between those two vertical lines. Well, in this particular case, it's range values, so these are going to be y's. So I want that entire stretch. So what is my lowest possible y value here? Well, in this case, it's in between 12,000 and 8,000. What's halfway between 12 and 8,000? Well, in this case, halfway in between 12 and 8,000 is going to be 10,000. Now, some of you are already looking at the answers and you're seeing your answer already. But let's finish the problem out. Let's make sure that we know what we're looking at. The highest possible range value is 16,000. And when I look at that, I see that, okay, my answer choice is going to be C. The set of all y such that